Cool. So after your job is submitted, um, so we mentioned earlier QStat. The most important piece of a QStat, at least to me, is still the job ID. So that first column, it is how you interact with Cobalt. You need to kill a job, alter job parameters. You can grab a job ID and take a look at it to get more information. I actually have QStat alias QStat-F because I find the -F output to be usually a little more useful than just that. We're going to pick on someone with something in queue. So I'm going to pick on someone entering CP2K. So I can do QStat-F and get the job information for that. I can pick on a particular user with QStat-FU and just get that particular user's job. If I don't want the long form, just that. And if I want the really long form and containing like, well, that one's a bad example, but a longer description, usually if a job is running, we'll pick on something that I think is running. You can get more details about what's going on with the QStat-F file. Looking at the QStat man pages, again, you can actually set up custom headers. You can adjust the QStat default output to be whatever you'd like. The one other command is QStat-Q. So if you have forgotten what the parameters like max wall clock time, or if you've got reservations and are worried about, did all the users get on it they intended, QStat-Q will show you queue information as opposed to job information, and that's QStat-Q. So everyone's favorite page in these parts, status.alcf.anl.gov, also known as the Gronkulator. It's basically a visual QStat that shows you what's running what and where. It'll show you what's queued, what's up next, and also what any reservations. The only thing it will not show you is jobs on hold, just because users have a tendency to leave a lot of jobs on hold, particularly with in-depth chains. There's one for Mira, for Cetus, for Vesta. Oh, we had to have gotten a better shot for Vesta. Cooley. And it's not in the slide deck, but there's also now one for Theta that has a slightly different resource. So what will Cobalt give me back when I put a job in queue? I will get 3 by default. I will get, if I use the -O with some sort of prefix, or my prefix _ $job ID, though I think it should be Cobalt job ID. It will create 3 files, prefix.cobalt log, which is kind of like the receipt for putting a job in the queue. It contains the information that operations needs to kind of reconstruct the job if something goes wrong without bothering you. There is the prefix, so usually job ID.error, which is created when the job starts. Anything that goes to standard error goes there. And we'll continue updating anything that goes to continue updating as long as the job is running. And then the job standard out file, which is normally job ID or prefix.output, which is anything that you sent to standard out. There is no per rank standard error or per rank standard out. Everything comes out in one torrent. So if you've got like 30,000 ranks all writing to standard out, it's kind of incumbent upon you as the user to straighten things out and avoid collisions if you're doing that. So we don't generally recommend folks do parallel IO to standard error and standard out. If something goes wrong, the find folks in operations, they get together once a week, they lock themselves in a room, and they go through every job on the system which has failed or has a non-zero exit code. And so the way you can make your local Blue Gene and Theta admins happy campers is by, if you have jobs that have failed, leaving in place the error Cobalt log and possibly the output file, so that way they have a chance to review what happened. Even if they don't get in touch with you, I know they deeply, deeply appreciate it. QDEL is self-explanatory. Deletes the job from the queue and will terminate running jobs. QAlter and QMove will let you alter the parameters of queue jobs without resubmitting. So say I typo my time, and instead of intending to run for 12 minutes, I went 12 hours. I can QAlter -T 12:00:00, get my hours, minutes, seconds back. You can QAlter multiple jobs. So in this case, they're showing changing the wall times of jobs 123, 124, and 125 plus 60 minutes. The only thing QAlter cannot do is change the queue. QMove again will move something. And generally, QMove is reserved for moving things, generally used by folks to move things that they accidentally put in, say, the production queues into a reservation queue. One important thing about QAlter is every time you run QAlter, what are referred to as submission filters rerun. So if you do something that changes a job from, say, changes its runtime from, say, 6 hours to 12 hours, the submission filters will run again and may move the job automatically for you from, say, prod short to prod long. Or if you increase the node count, it may kick it from prod short to prod capability. One important thing that's upcoming, and this will be disclosed in our scheduling policy, is when something kicks a job between queues, it will reset the score to avoid folks kind of gaming the queues. But that's an upcoming change. Again, queue hold, queue release. Queue hold will leave a job in what's referred to as user hold. Queue release will release anything that's in user hold or in dep hold, and again in dependency holds. It will not release anything in an admin hold. So if you find all of your jobs in admin hold, it's usually a pretty good sign that a systems administrator is looking for you. Reasons things might not be running. Again, show res, there may be a reservation in place. There may not be partitions available. So there's a command on our Blue Gene Systems part list that will give you a list of all available partitions, and if it's blocked, what subpartition is blocking it. So if I do like part less grep idle, I can grab all the idle partitions. In this case, I can see that a bunch of the idle partitions are assigned to the training queue. And so I can kind of go, oh, well, I'm on the training reservation. I should be able to run on those partitions. If something is broken or offline for other purposes, it will usually, well, today's a good day. Actually, most days are a good day. There'll be some sort of message noting that it's offline and kind of enlisting why. Otherwise, the next common one is blocked because there's a subpartition in use. So again, to kind of bring things up, I think this slide is awful, but and they'll explain why again. Small, long jobs that are submitted to prod are restricted to prod long and therefore only to row 0, so a third of the machine. If you can get cut your job length in half to keep it below 6 hours, then you're eligible for price short, which kind of helps your job's priority out. The best thing you can do again is to run capability class jobs that are using 20% of the machine or more. And this is true across the board. The bigger your job, the more priority it'll get, the faster it'll run. And those jobs land anything that's 4096K or larger, well, 4096, yeah, 4096, larger than 4096 nodes, that's to say using an 8K partition or larger, will wind up in prod capability. They can run on row 0, row 1, row 2. Operations and the entire staff were very responsive to help us get this large job through the queue. It's kind of the reason for the leadership computing facilities. The bigger you submit and the bigger the job you submit, the happier we are and the more we will make sure that those jobs make it through. There's a suggestion here, if your job is amenable, submit a mix of job sizes and lengths. Again, you can only have 5 jobs running at once, 20 queued. I wouldn't do that myself. Instead, I would emphasize bundling my smaller jobs together in order to achieve capability sizes. I would do my best to submit capability jobs in the first place. And if I'm in one of those situations where I cannot get the capability sizes, or I just cannot bundle enough things together in a reliable fashion, the next thing I would do is actually to use depth chains and try to keep my jobs small and short, preferably shorter than 6 hours, such that they can make it through the queue, and with depth chains that they can be arranged in such a way that operations can see that this list of things has to happen and can schedule accordingly. So you can also make use of the backfill window. So again, part list becomes your friend because you can see if something is draining at a given time. On Vesta, where I'm logged in right now, it's kind of a bad example, but you'll see there's a backfill column. And right now we don't have anything backfill. We don't have a backfill queue on Vesta. But that backfill window in the slide shows that that 1024 node partition is idle, and the backfill window is 49 minutes. So if you have a job that can finish in 49 minutes and make use of that, it's generally about as good as yours.